Hello and welcome to another episode of Peep and EIP, an EIP focused series where we discuss one improvement proposal and understand why that is considered for the Ethereum network. Today we are going to learn about EIP-2718 typed transaction envelope, and our guest is Micah Zoltu, who is also the author of this proposal and one of the EIP editors of EIP repository. We are also joined by James, the hardfork coordinator, Lightclient, and our Cat Herders member, Jim, Brent, and William. EIP 2718 is a standard track core EIP that was proposed in June this year. And according to summary provided in the proposal, it is defined as a new transaction type that is an envelope for future transaction types. To be more specific, for EIP 1559 transaction type. So this proposal is added in the list for YOLO V3, which is at the moment is EIPs considered for Berlin. Without further delay, let me welcome Micah. Micah, thank you for joining us today. Please let us know something about you, your engagement with the Ethereum community, and then we will get into the proposal.
Thanks, Pooja. My name is Micah, as introduced. My involvement with Ethereum is that annoying guy on the side that comments on everything but doesn't actually have a role. I participate in EIPs. The reason I became an EIP editor originally was because I was tired of my EIPs not getting seen by anybody, and so I said, hey, I'll look at all of them because it means I can look at mine too. So definitely not good reasons there. I also participate in some of the, I show up to the core devs call and annoyingly interject my opinions periodically. The reason for that is I want to make Ethereum better because I'm a firm believer in the project and as a whole. And so I, of course, have opinions on everything. My background is in software engineering. I've been doing software for, I don't know, almost 20 years now, maybe. God, that makes me sound so old. So this EIP, without further ado, a little bit of history. Back when Ethereum started, there was one transaction type, and that transaction type was just you'd have a to field where the transaction is going, and you have a data field, so you can include any data you want along with the transaction. And you have like the other stuff like gas and how much ETH you want to attach, stuff like that. The data field was kind of overloaded to be used for contracts. And so when you wanted to call a contract, you'd send some data along with it, and the contract would interpret what that data means. Over time, eventually, Solidity gained prominence, and now basically everything in Ethereum interprets the data field the way Solidity interprets it, because just about everything is a Solidity contract. The other thing that data field is used for is for deploying transactions. And so when you send a transaction and you want to deploy deploying contracts. So when you want to deploy a new contract, you would fill the data field with some code that you want to be executed on chain. And then at the end of that will return the contract that you want to deploy. And then when you do that, you'd send it to the address 0, and that's your destination because there's no recipient. You're not sending it to anything. And so it kind of special cases that. And so even from the beginning, as you can see there, we've kind of had two transactions. They're just both overloaded the same set of fields. So we had the to field, and if the to field was 0, then it means that this is a contract deploy, and we should interpret the data field a certain way. And if the to field was not 0, then the data field should be interpreted differently. But because both of these use the same kind of size and order of fields, we were able to kind of smash them together and just have one transaction type and one signature type. So when you sign a transaction, you sign it in this particular way, and everybody signs a transaction in the same way. And gas is paid in the same way for all of them. And so it generally has worked. Over time, however, we have found more and more needs here and there for wanting other things in a transaction. We first saw this in EIP-155, if I remember correctly, which was I actually can show you here. So the EIP-155, which was simple replay attack protection. And for those of you that have looked at this, it's this kind of complicated bit munging thing we do where we make it so a transaction that is destined for Ethereum mainnet will not work on Ethereum Classic or Ethereum testnets like Ropsten or Coven, or vice versa. If it was destined for Ethereum Classic, it will not work on Ethereum. But in order to do that, because we only have one transaction type, we kind of have to smash a bunch of things together. And so you have this weird stuff where if the V value, which is, I forget which field it is, but if the V value in the signature is a number that is greater than 35, then you need to interpret a certain way. If it's a number that's 27 or 28, then you interpret a different way. And so this is unfortunate because for developers who are trying to integrate with Ethereum, you now need to have this weird logic where you have to look at the transaction and look at the different fields and say, okay, if the to field is 0, then we interpret it this way. If the to field is not 0, we interpret it this other way. But if the V value is this, then we need to extract this other piece of data out of the V value, which is kind of bit packed in there. And if the V value is 27 or 28, though, we need to do it this other way. And so now we're up to kind of sort of 3 or 4 transactions, depending on how you count them, that are all using the same structure. And so they're all using that same structure to try to convey 3 or 4 different meanings, but with the same data set, with the same data structure. And so again, as Ethereum developers, client developers, tool developers, integration developers, and even dApp developers in some situations now have to all deal with this. Like they have to understand all the different ways that you can smash a transaction together to get different results. This is a big headache. Yep, go ahead.
So there's like an order of how we manage transactions. Is that something that is like software is enforcing it, or is it just sort of we all started to agree and then now it's kind of the standard thing? You mean
for
like the pattern of how we use transactions? That everything is kind of a contract of it.
So it's it is software enforced. So this all is consensus. And so if the to field is 0, then all the different clients do need to interpret the data field as a contract deployment, and they need to execute it in a certain way because every client in Ethereum acts in lockstep with each other, which means that they all need to make sure they make the exact same changes at the exact same time. So when you're processing block 1, 2, 3, 4, 5, you all need to make sure that the result of processing that block ends up with the exact same state change. And so these are all consensus concerns, which means that it is enforced in the code.
Okay.
As to how we ended up using, kind of reusing these fields, at the time, it was just the easiest thing for humans to do. So rather than trying to introduce a new transaction type back when EIP-155 was around, it was decided that, that sounds complicated. Let's just agree. Let's just all agree. All the clients will all agree to interpret the V field differently from here on out. And so that was the hard fork that 155 was included in, was a consensus change hard fork, because all the clients needed to agree, okay, this is the way we're now going to interpret that field from now on. Does that make sense? And does that answer your question?
Yeah. And so then now there's a whole bunch of things that happen at the code layer that people need to think about that isn't like totally obvious. The app layer.
Yes, exactly.
So, all that stuff.
Yeah, so a new person wants to come in and create a client. Besu, I think, is our newest client, if I'm not mistaken. And so when they go and implement Ethereum, they now need to understand all these little idiosyncrasies. And the more idiosyncrasies like this we have, the harder it becomes for new developers to enter Ethereum and start developing and start building things, stuff like that. And interestingly, as a slight tangent, the part of the reason that we're hesitant to introduce new EIPs is because that code does need to live forever. And so when EIP was introduced a long time ago, even if we introduced 2718, 155, the code for 155 will still live on. And every single new client will need to understand it. And most likely, most apps will also need to understand it. And most tools will need to understand it. So introducing 2718, which we'll get into in a minute, doesn't actually resolve that problem of all these people now needing to understand all those idiosyncrasies. It's more about preventing new idiosyncrasies from being introduced that add even more complexity. So we want it so as we add new features in the future, they're not increasing the complexity any more than necessary. So a couple of examples, we have EIP 1559 and 2711 potentially, and 2930. All of these will introduce new transaction types. And when they do, we want to minimize the long-term damage they do in terms of the complexity for new developers entering the ecosystem. So when someone shows up in 5 or 10 years and they want to develop for Ethereum, we don't want them to have to deal with, okay, here's the 4,000 different little things we tacked on to a transaction and the 72 different ways that you need to interpret these different fields depending on what this number is. Okay, so if transaction, if the to field is this, then that means this, and then we've run out of places we can jam stuff in there. So now we're going to start saying if the gas is 0, then that means these other fields mean these other things. We want to avoid that. We can't undo the past in Ethereum, unfortunately, but
So
we can
by
at
that
least
you mean
protect the future.
EIP-155, that damage is done, and we always have to include that damage for the rest of history, and we can't remove that. Is that what I hear you saying?
Yes, that is correct. So that choice in 155, which I will not say that the choice was wrong at the time. It made sense at the time, and
Right.
but this
now it's cast
complexity
in
will always
stone.
live with us to a certain extent. Yeah, exactly. It will live with us forever. There are some, again, as a slight tangent, there are some proposals of mechanisms for kind of getting rid of old Ethereum choices. Those ones are kind of very future looking, though. Don't expect them anytime soon. Things like regenesis or minting a new Genesis block in general would maybe allow us to do that. But that's some complex stuff that people are talking about on the side, but it's definitely not on any roadmap right now. So for the general idea, you should assume that changes in Ethereum will live with us forever if their consensus changes, like 155. Like you said, they're cast in stone. So 2718. The idea here is to create a mechanism whereby we can introduce new transaction types in the future without having to try to jam them all together, yet having a consistent mechanism of identifying what those different transaction types are. And so as I mentioned a moment ago, we have 1559, we have 2711, we have 2930, and several others that all kind of propose to introduce new transaction types. And so we'd rather have a consistent story for all of them and be able to say, okay, this is how you identify what type of transaction it is so that you know how to interpret the data. Because over the wire, when clients are communicating with each other over a gossip network, they're just sending bytes to each other. And so they need to agree in advance how those bytes are structured and what they mean. And so when someone receives a list of transactions, they need to know how to interpret that list. And so the idea with 2718 is to give a consistent way to interpret that. And now finally here, the way to do that is the very first byte of a transaction will represent the transaction type, which means we have not quite 255. We'll get into why not down below, but for now, we can just say we have, let's say, over 128 transaction types, which given the rate at which we introduce new transactions, like I said, we started with 2, we introduced 155, which introduced, let's say, 2 more. And so we've only got up to 4 and for several years. And so we're not thinking we're going to need like thousands of these. And so we have 1 byte, which gives us maybe 100 or 200 of them. And so when someone wants to create a new transaction type, it's, again, still a consensus change. All the clients still need to agree on it. But now we'll at least have a consistent way of interpreting it and presenting that when they're gossiping. So when you're gossiping with each other and you send a big bucket of bytes and you say, hey, here's a list of transactions, someone knows how to iterate through those bytes and say, okay, this first byte says it's type 0. And so that means I interpret the next n bytes in this particular way. Or it says, oh, this byte, first byte is 7. So that means I interpret it this other way. But in the code, that's very simple because you can just say, okay, if it's 0, then do this. If it's 1, do this. If it's 2, do this. Instead of saying, okay, if the v value is this and the 2 value is that, then we need to interpret it this a certain way. But if the v value is greater than this number but less than that number, then we need to interpret it this other way. And so doing it the way we were doing it previously just is a lot more complexity in code. And for those that aren't software engineers, it's hard to explain where this complexity comes from. Just know that if it's harder to explain in human words, it's probably hard to explain to a computer as well. And so if it's easy for me to say, oh, if that first byte is 5, then this is how you interpret it. It's harder for me to say, if the first byte is 5 and the second byte is 7 and the third byte is divisible by 3, then do that. So the second way is harder to describe, both to a human and to a computer. So that's pretty much all 2718 is, really. It's just a mechanism for describing how transactions, how you identify the mechanism to interpret the bytes of a transaction. As part of that, we also need to deal with receipts. So for those of you that aren't deep in Ethereum, a transaction receipt is a piece of data that all the clients agree on, so it's part of consensus. And they all agree that this is a high-level overview of what happened in a transaction. And so when a transaction happens, a receipt is generated. All the clients generate a receipt, and that receipt is, they all generate it separately because they're acting in locksteps. They all do the same thing at the same time. And then when the block is passed around, they all look at that and they say, oh, yep, I got that same number. Oh, yep, I got that same number. Oh, yep, I got that same number. And so that's the receipt. And so we need to make sure that they all generate the receipts the same. And so, and we want to change the receipt because future transactions may also have a new receipt type. So currently for transactions, the receipt contains a status and a cumulative gas used, logs bloom, and a logs array, I believe. I'll need to check that. But I'm pretty sure this is just an array of logs. In the future, we may have a transaction type that will never generate logs. And so we don't necessarily need this, the logs bloom or the logs. We can just save some bytes by not including them. Or maybe in the future, we'll have a transaction type that does batch transactions, in which case the receipt may become more complex because there's multiple transactions that all need receipts. And so you need like an array of receipts. And so because of that, we want to make it so the receipt can iterate along with the transaction. And it works basically the same way. The transaction type is the first byte, and that tells you how to interpret the rest of the receipt. Any questions so far before I get into like the nitty-gritty details that I'm sure no one cares about? No? Okay.
This is a great overview. Thank you. Yeah, I'm following along.
Yeah, it's great. Thanks.
Excellent. So getting into the rationale section. So for those of you that aren't deep into EIP editing, EIPs contain several sections. We've got the abstract, the simple summary, which are kind of self-explanatory. We won't go into them today. Motivation talks about why we want to do this. Specification talks about the very technical details of this is what this specification does. The rationale section is used for describing why certain choices were made within a transaction. So in this transaction, you might ask, well, why did you choose to use concatenation here instead of something else? Or why did you, like the one we've got here, why did we only go up to transaction type 7F instead of going higher? And so these are all just like little nuances and details for why we chose do what we do. Let's start with an easy one here. So in the specification, there's a way of communicating where we use the words must or should. And this indicates the strength which we're saying something. If you say must in a specification, you're saying you must do this or you are doing it wrong. If you do not do this, you are wrong. And in the case of consensus, like we said, when those clients are all working together in lockstep, if you don't do a must, then you will be kicked out. Like none of the other clients will talk to you. They'll all stop talking to you because you're doing it wrong. If something is a should, though, it's saying, really, the authors of this EIP really think you should do this thing. It's a good idea. But if you don't do it, you're not technically wrong. Like we really think this is a good idea, but maybe it's okay if you don't. And usually that's used if there's certain situations that we know exist that are like, well, we know there will be a time when this is not true, and we want to make it so that's okay. But we really still would rather people not do them. So this is one example of that. And so we recommend using the should wording that future transaction types should include the first byte in the data that they sign. So when they sign something, this transaction type, so I was saying this is just a single byte, it's a number. If we've got, I create a new EIP and I introduce a new transaction type and it's type 7, when I sign that transaction, I should include that 7 as the first byte of the payload. And the reason for that is it makes it so we don't have to worry in the future about different transaction types sharing a signature, because this introduces a whole new attack surface area. And in fact, this is part of the reason that some of the complexity is introduced when we have these new transaction types, because we don't want to make it so if you send a transaction, it could be interpreted as one of two different things, specifically the stuff that's signed. So imagine if you signed a piece of paper and there was a little spot on it that was left blank. and someone could fill it in with one of two words, and your signature is valid whether they choose word 1 or word 2. And word 1 and word 2 may result in different meanings for that contract. And so you don't want to sign a contract that can be changed or is mutable. And this is called in Bitcoin, it's called kind of related to transaction mutability. And so what it means is that the signature doesn't cover enough data to guarantee that the thing you signed is the thing that someone interpreted it as. And so we want to be careful of that. And so if we have two transactions that are pretty close to each other, again, remember, just bytes and a wire. We want to make sure that if someone signs a set of bytes, that someone else can't submit that bytes to the network and have them interpreted a different way. And so by signing that transaction type byte as the first byte, we give pretty strong guarantees. In fact, I believe hard guarantees.
Yeah, that's pretty strong.
That this transaction cannot be interpreted in two different ways. Like that, if you have a signature of this, you can't interpret it some other way because each transaction type is interpreted one very specific way, and each transaction type has its own number, transaction type number. And so they're guaranteed to be different. This sounds like something that should be a must. Like we should have hard guarantees that we must do this thing, but we don't. The reason for that is because we are not starting from zero. We're not starting from a clean slate where we can say that all transactions ever will follow this rule, because we've been going for 4 or 6 or however many years it's been now with transactions that do not follow these new rules. And we want to make sure that those transactions are still valid because we have existing tools that are out there. We have hardware wallets. We have offline wallets, people who have wallets, that are on computers that have never connected to the internet and they don't want to ever connect to the internet. We have hardware wallets like Ledger or the Trezor, and they have signing built into them that may not be easy to change. And so because of that, we can't say that this has to be that way because we already have an example today where it's not that way. And this is still okay. We could say, okay, well, if you're a legacy transaction, which doesn't actually use a transaction type at all, then you're okay to sign it a different way. But what we want is we want to eventually make it so legacy transactions are now also type transactions. And so they follow the same typing system to try to get rid of a little bit of that kind of legacy code. Like I said before, we can't delete any code, but we can at least make it so new tools who are only working with new transactions, particularly like application developers or JavaScript library developers, we can try to make it so at least they don't have to deal with the old stuff. So Ethereum clients always have to deal with the old stuff. But some of the other things on the edges, we might be able to get to a place where they don't have to deal with the old stuff. And so we want to turn the old transaction types, the stuff that we've been signing for years, we want to make it so you can still sign them using the same tools like hardware wallets, offline wallets, stuff like that. And also, have signatures that maybe you generated a signature 4 years ago and you wrote the signature down and laminated it, buried it under your house. And, in 30 years, you plan on demolishing your house and digging it up. And so you want to make sure that transaction signature is still valid for those people. But we want to make it so when we're communicating about that transaction over the gossip network and, just in general, tools are dealing with it, they don't have to deal with that old code. So because we want to make those signatures still valid and we want to have them have a transaction type, we need to make sure that that's why this is a should. Again, because we can't quite say this is a must, but really, really, really we mean you really should do this unless you have a very specific situation. And that specific situation that we know about right now is legacy transactions. Let's see, we've got, so this one actually came out very recently. So I'll be quick on this one because it's pretty technical and I don't know. Okay, so I'll be semi-quick on this one. So historically, all transactions have been encoded with RLP, which is a particular encoding scheme for encoding bytes when you're ready to transport them over the wire. There's lots of different encoding schemes on the internet for encoding data. RLP is one of them that Ethereum uses. I don't actually know if it's used anywhere other than Ethereum, but it's used almost everywhere in Ethereum. So originally, we actually said that the transaction type, instead of concatenating the transaction bytes, oops, sorry, up here, on the end of the transaction type. So you'd have the first byte is a transaction type, and then you'd have just all the other bytes after that are the transaction itself. Originally, we had to actually be an RLP encoded list. So you'd have a list of 2 items. So first the transaction type, and then you'd have the next item in the list would be the transaction. And that transaction would just be maybe an RLP encoded thing. However, we want in the future, part of this is we want this EIP to make it possible to introduce new transaction types that may be formatted differently, and that formatting could include different encodings. ETH2, for example, is likely to use SSZ encoding instead of RLP for a lot of its stuff. And so there might be a situation in the future where we need a transaction type in Ethereum that would really make a lot more sense if it was SSZ encoded, or maybe we get benefits for SSZ encoding. I think there's some Merkleization benefits that I'm not super familiar with SSZ encoding that we may be able to benefit from in the future. And so rather than, we still could do that. We could still have an RLP wrapper and then SSZ inside of that. But we want to make it so the, sorry, got distracted. We want to make it so that if in the future we switch to SSZ for a bunch of stuff, we're not stuck forever with RLP. Now you could just say, well, I mean, you have to choose between RLP or truncation, which truncation is what we're doing. Either way, you're encoding something. The advantage with truncation is really, really easy. You don't even need a library to decode it. So when you're decoding a thing like an array of bytes, it's very easy in every language that I know of to just strip off the first byte, read it, and then read the rest of the bytes separately. Like that is a simple thing to do. You don't need any special decoder. You don't need any special software. You can do it with, a human can do it with their eyeballs. Like this is so trivially easy to do everywhere that you don't need to really think about it. Like it doesn't take even a second thought to figure out how to do it. Like everybody who has been software engineering for a while knows how to do this naturally. Like it's a very simple thing. RLP, on the other hand, while it's a fairly simple encoding mechanism, you do need a library to decode stuff. Like it's complicated enough, and it's variable length, which means like, okay, so you read the first byte, and then if the first byte is in this range of numbers, then you need to read the next n bytes in a specific way. Whereas if it's in this other range of numbers, then the next n bytes means something different. And so it becomes complicated to read RLP, complicated enough that you almost always are going to want to use a library for it. If in the future we move to SSZ in a lot of places, it might be that some places don't actually need to understand RLP at all. Like right now, there are application developers out there who are developing for Ethereum who don't know RLP. There are also application developers who know RLP only because they need to know it so they can encode a transaction. Like that's the only reason they need to know it. In fact, I was one of those for a while where I learned RLP because I needed to know how to encode a transaction. That's the only thing I needed it for a long time. In the future, again, thinking 5 or 10 years in the future, if SSZ is the encoding internally, we don't want to have every author either learn how to do RLP stuff or find a library for RLP just so they can decode, those 2 items. Like we want to avoid that. And so that's why we're going with a not using RLP and instead using concatenation. And actually, I just realized I answered that question. That is not what this question is. I need to add this to the rationale as I went over this again today with somebody. Same thing. So
I remember a lot of this conversation.
Sorry, go ahead.
I remember a lot of this conversation happening. It's fun to see the resolution to a bunch of these things.
Yeah, we've talked about this several times. And many of these have come up multiple times. That's usually how things end up in the rationale, at least for my process, is I write the IP and the rationale is mostly blank. And then someone will ask me a question, and then someone will ask me the same question. And so at that point say, okay, clearly this is not clear to users, and so I need to add a rationale for it. And so in fact, the answer I just gave is a rationale that I've recently answered yet again, and so I should include that. The one I was trying to answer was why we're doing opaque bytes for and I got distracted. So we see here they have the transaction type, which is a byte, and then just bytes, like transaction payload is just a byte array. This is not anything specific. This is so we can use SSZ internally or RLP internally or LEB-128 internally or fixed width format internally. Whatever we want can be used in future transactions. And that leads into that other answer I just gave where, okay, well then why are we concatenating? It's basically the same thing. We're concatenating because we want to because this may not be RLP and we don't want to have to do RLP just to extract 2 values. Like that sucks. I'll probably skip these then, leave to make sure there's time for Q&A. Most of these I think are pretty self-explanatory. So if you are someone who's implementing this, I do recommend reading the rationale. There's a good chance that your question has been answered already, and it is in here. Most of the questions I get are things that are in the rationale. I don't blame people for not reading it. I don't hold it against them because I know that by the time you get through the specification, your head hurts and you're tired, and you don't really want to read more. But there's a good chance your question is answered in the rationale. So I do encourage people to read the rationale if you have questions about any EIP. So you know where the should instead of must. Transaction type only goes 7F. Right. So earlier I mentioned that transaction types are a single byte, and a single byte can hold 255 numbers. Actually 256, I think, right? Yeah, it's one of those two. But we say in here that transactions are only valid with types up to 7F, which is only about 128.
It depends on if you count 0.
Okay, so it's 127, 128, 129, somewhere in there. Specifics don't matter here. What matters is that it's about half of the available numbers. And so you might think, well, why are we limiting ourselves to only half the numbers? That seems like a waste. Again, we don't think we're going to need that many. Like in the last 4 or 6 years, or however long Ethereum's been around, we have only used arguably 4. Like if we had this at the start, we would have 4 maybe at this point. So we're not worried too much about running out of numbers. And also, this gets back into the transaction malleability. All legacy transactions will start with a number that is greater than C0 in hex. And so we want to make sure that those don't overlap with some future number. We don't want someone to come along and say, oh, my new transaction type is C1, and then have that be malleable with a legacy transaction, meaning a single signature could apply to both. We really want to avoid having to worry about that problem because it's a very easy problem to screw up, and it's a very easy problem to overlook. It's a very easy problem to make a mistake on. And so rather than having to deal with those problems, we're just saying, hey, if your transaction type must be a number between 0 and 7F. The legacy transactions technically start with a number in the range, I thought I had it written down here, but apparently not. I think it's C0 up to something. I forget what exactly. But what's important is it doesn't include FF, which is all the bits set. So if we do run out of transaction type numbers, so we've used up 0 through 128 or whatever it is, and then we've said, okay, well, anything greater than C0 is invalid. We are still left with FF, which we can use as an extension indicator. So if we could say in a future EIP, for example, we could say, okay, if that first byte is FF, then it means the next byte is really where you look to see the transaction type. And we can kind of extend that way. I don't think we're going to get there, at least no time soon, based on the rate at which new EIPs are introduced and everything. It's unlikely we'll ever get there. But if we do, we have an out. Like we've reserved FF as well for extending the range of transaction types. As I mentioned earlier in this discussion, one of the things we're trying to do here is make it so the complexity goes down. Introducing FF as an extension byte would increase complexity fairly noticeably. And so I'm really hoping we don't get there, but I'm pretty confident we won't. And so I'm pretty confident 7F is going to be enough. Just because Ethereum doesn't move that fast. The rate of changes to the Ethereum clients isn't so high that we're introducing transaction types every week. Like I'm thinking, one transaction type or two. We'll probably have a few burst at the beginning. Like once we introduce this, there's a bunch of different EIPs that have kind of been waiting to be introduced, but we don't have this mechanism yet, and so they've been lagging. Like it's hard to get them through. So we might see a burst of this once this EIP goes through, but I suspect realistically like 1 a year maybe of new transaction types, maybe 2. And so that gives us, 64 years, at which point I don't care anymore. So it works for me.
64 years is long enough. I'll be gone.
Yeah, exactly. That's someone else's problem at that point. Hopefully we have AIs writing code for us at that point, and so it's their problem now, not even human problem.
Yeah.
Yep.
Which would be nice. So origin versus color. So in Ethereum, in the EVM, there's opcodes which you can call. One of those is the origin opcode. The other one is the caller opcode. And what the origin does, it tells you who. It's kind of vague. Right now, it basically tells you who signed the transaction. So this is the address of the person who signed the transaction. The caller opcode is the one that says who is the person that called this specific call frame. When you have new transaction types, the caller and the origin, the caller for the first frame and the origin may not mean the same thing anymore, because what it means to sign a transaction may change. For example, let's say we introduced a new multi-sig transaction type where a single transaction includes 2 signatures. Well, now, so we can't just look at the signature alone and determine what the address is. So maybe we have some new mechanism for determining address, or maybe the like what caller means or what origin means isn't super well defined anymore. Like, because we have these new types of transactions, it may introduce new signing mechanisms. We have account abstraction on the horizon, which if it makes it in, we'll hopefully use 2718. In which case, like, it's not super clear that this will always mean what is meant historically. So we have to deal with that. And the way we deal with that in this EIP is by saying we're not going to deal with it. So basically we say EIP-2718 does not specify what origin and caller means. It is up to individual new transaction types to specify that, but we recommend that you try to treat them as basically the same thing as they mean today. So when you're introducing a new transaction type, do your best to map origin and the first frame caller to something that is basically means the same thing it does today, because a lot of contracts do look at those and they do care very much about what those are, and we want the semantics to kind of stay stable across transaction types, as stable as we can. Again, we can't see the future, so we don't know what new transaction types will be. Maybe there'll be some where just origin makes no sense at all, and we'll have to deal with that when the time comes. But basically, we say that's up to each new transaction types needs to define what these mean. And it's pretty simple in most cases that we can see for the foreseeable future. It might not be in the future. Went over that. So a question I have been asked is, how do I choose my transaction type number? And the answer for that is basically however you want, sort of. We're not defining it in this EIP. Like, some people have proposed, well, what if we have a list somewhere that lists all the different transaction types? We could. However, I suspect we're going to get like maybe one a year. And so I'm not too worried about running into like conflicts or anything. Also, when these are being implemented in clients, like at the time of implementation, they will need to choose numbers that are unique, or everything will immediately fail and it will be obvious why. And so we're basically saying, choose a number that's not taken yet, probably something that's next in line, so it's easy to keep track of what is taken. But this EIP does not define a specific way to do that. If we were expecting this like new transaction types to come about every month or so or faster, then yeah, we'd probably want some list somewhere that maybe lives in the EIP repository or somewhere else that keeps track of these. But for now, at least, we're saying we don't think that's necessary. That's subject to change, of course. If it turns out that this is a big problem, then maybe we'll keep a list somewhere. Here's the thing I was looking for. So legacy transactions will go between C0 and FE. FF is not realistic. I think technically in RLP, FF is valid, but FF for the first byte, if the length of the transaction is 255 bytes long, meaning the number that defines the length is a full 256-bit number, and it needs all the bytes. So you're looking at, it means your transaction is bigger than the memory of all computers on the planet, kind of thing. Maybe even all the stars in the galaxy. I don't remember. So FF will never be used. That's why we set that aside.
Not realistic. In the computer,
I think that's everything in this EIP. We've at least covered all of it at a high level. Again, if you're implementing this, I do not recommend you use this video alone for your implementation. I recommend you actually, I recommend you read the EIP if you're going to implement this, specifically the specification section. You can kind of ignore the rationale section unless you want to know the why. But yeah, hopefully that gives a high enough level overview. So, anyone have questions?
Yes, I have a couple. Or I'm curious of the origin story of how the idea of the EIP, and then actually when was decided to like hit go on it. It's like the coming to write this EIP.
So the origin story, right? So the origin story for this is actually another EIP, EIP-2711.
Classic.
So EIP-2711, not the topic of this conversation, so I won't go into details, but basically, yeah, yes, exactly. And the origin for 2711 was another EIP. It goes all the way down. It's EIPs all the way down.
EIPs all the way down
until it's elephants or turtles. Yes. So 2711 was introducing several new transaction types, or sort of one new transaction type, you could argue, but that had subtypes. And originally, I actually folded in this change, this new transaction type concept, into 2711 or 2718.
Mm-hmm.
Pretty quickly, however, I realized that was not. It doesn't scale very well because, it would solve my problem for 2711, but it won't solve 1559. It won't solve for 2930. It won't solve for anything else. It was just me solving my own problem. And so what I did at that point is I basically extracted out just the little bit about how do we do type transactions into its own EIP, and then wrote that. This one in particular, just as a very brief overview, was going to introduce transaction batches, so you could send multiple transactions in one transaction. It's like they do multiple things in a row. It was also going to introduce sponsorship, meaning someone else could pay for your gas instead of you. And it was going to introduce expirations, where a transaction is valid until some time stamp is reached, at which point it becomes invalid. And not all of those may make it to the end. The CIP may not make it all the way, so we won't go over that now. But that was the genesis. That was where this came from.
I remember seeing.
Does that answer your question, James?
Yeah, it does. I remember seeing. Well, I was working on 1559, and then I saw this.
I see James's name, but I don't hear. Am I disconnected?
Oh, the internet. He's typing. Oh, I'm he's lagging. He's gonna reconnect in the text chat, just for context of viewers.
So I guess we roll commercials here.
Yeah. Well, I can give some context of I was working on 1559, and then I saw this EIP show up, and it's like, yes, thank you. Someone has done this, because it simplifies the implementation on a client level for doing 1559, which is the fee mechanism upgrade that they're working on. So then that was being worked on separately, and I just so now here we are, and hopefully Micah comes back soon.
Yeah, it's actually funny because I don't think that we've had so many different transaction ideas until just this summer. And while it came out and a lot of people were working on 1559 like yourself, we were working on account abstraction. And the way we were originally planning to do account abstraction was just saying, oh, the signature will just be all zeros. The to address will be some, random, some specific precompile, and that's how we're going to kind of hash type transaction in. And in June, whenever Micah was talking about 2718, we realized that this was going to be the perfect fit for us. So it's funny how it kind of came at the time that it was needed for a lot of people.
Yeah.
Okay, I'm back. Sorry about that. A banana leaf must have fallen in front of my house or something.
Yeah.
I have a question for you, Micah.
Yep.
So you've proposed this, early in June, and you've authored quite a few EIPs in the last few years. I think I just looked it up. You have 13 EIPs to your name so far. So I wondered if you could just talk about what the process has been like since June to get this EIP pretty much on the docket for Berlin. It seems like a very strong contender for Berlin, and maybe how other EIPs fall short and end up never progressing to a hard port, even if that's their end goal.
Sure, I can try. So my number one recommendation for EIP authors is keep your EIP as simple as possible. The one thing I've noticed is that client developers, who are the ones who are deciding what goes into the hard forks largely, are very busy people. They do not have a lot of time to read a very long-winded IP. They are oftentimes just skimming over it, like right before an all-core devs meeting, or sometimes in a all-core devs meeting, someone will bring it up and they'll quickly open it up and read it over. If your EIP is very, very wordy and long-winded, there's a good chance that it will get pushback, not because it's a bad EIP, but just because the core developers are very busy and they don't have time to really dig into it deeply. And so if you're writing an EIP and you want to go through simply, keep it short, keep it simple, keep things very focused, very on point. And this isn't just for this EIP. I've noticed this for all EIPs. The smaller the EIP is, the more likely it is to go through. And you actually see this in a lot of the older EIPs. Many of the ones that have made it in are all very short. They're like, 3 sentences.
Mm-hmm.
They change one thing, they do something very small. It's much easier to get a small change through than a big change. Also, if your EIP is particularly complex, it's harder to get through because you end up with this problem where someone may disagree with one little thing in it, and then that blocks the whole process or slows down the whole process. Whereas if you have separate EIPs, most of them can go through, and then you can focus the discussion better on the one little thing that's different. So in the case of 2711, there was a bunch of contention around transaction batches and expirations. And while sponsorship generally has been well received, it's kind of stuck because there's debate on the other aspects of it. And there's now debate on the sponsorship as well. But that was a problem. And so I had drafted this EIP, and this EIP is still pretty short compared to some EIPs, but it kind of puts a bunch of things together, and that has caused it to slow down. And it's part of why I extracted 2718 out as well, is because it could be extracted. So if you have an EIP and you can split it up into multiple smaller EIPs, I strongly recommend you do that. That will really increase your chances. And again, for 2718, the actual specification is very small. Like, you can fit it all on one page here. It's, basically 2 paragraphs that cover all of it. And it's really simple. You can keep it in your head. Someone can scan it in the middle of a meeting and get the gist of what it does. The abstract also, it's again, because people are often in a hurry, having an abstract that gives a very, very quick overview to someone who wants to implement this, so they can get the idea rapidly. That's very important. And simple summary, also important to keep it simple and short. Some people I see, their abstracts are like 6 paragraphs long, and you don't want a 6-paragraph long abstract because no one will read that. Like, you want to, you need to engage people rapidly, get them to decide whether they like this idea or not fast. And then once they do decide they like the idea, make it easy for them to identify, like, read the spec to see, okay, is there anything in here that stands out to me is going to be a problem? And again, make sure it's separated out as much as you can, because you want to make it so you don't want one piece of your change to block the rest of your change if they could go separately. Even if they go in the same, they make it into the same hard fork, there is value in having them separate, because just for getting people to talk about it and getting people to think about it, it's easier if they're separate EIPs. As for this particular one, I think the reason it went through is, like you were saying just a moment ago, there's a bunch of stuff that kind of wants this all at the same time. You've got account abstraction, you've got 1559, you've got 2711. There's actually several other proposals that are contending with 2711 that do some similar things. And they all, and 2930, which is also going in. 2930, interestingly, I wrote this for 2711, but it's most likely going to go through because of 2930. So 2930 is totally unrelated. I didn't know it existed at the time. It's just this thing that someone else had. And they're like, oh, if we do this thing, we should really use 2718. So by splitting it up into multiple smaller EIPs, it turns out that I got someone else to sort of lobby for my EIP for me, because it was a small little piece and other people could use that building block. And so now I gained the advantage of having other people saying, oh yeah, we should do that, instead of just me trying to lobby for it for myself. So, and another reason to do small EIPs, they can be building blocks and other people can build other EIPs off of them, which is valuable.
Yeah. And some fun context. Another thing when writing an EIP, if you're trying to do something like we were going to have account versioning, and then we scrapped that because we didn't want to do something without also implementing the thing. Like, this is one of those forward looking, making sure that the future is paved well. but core developers like to have a first step on the road at the same time we're doing the thing. So 29 to is it 2930?
Yes.
Is that we
Yeah,
want
2930.
this kind of a transaction envelope, but we didn't want to include a transaction envelopes without also including a transaction, a new type.
Yes, very true. And that actually, there's a good chance 2718 wasn't going to make it to Berlin because even though everybody agreed, yeah, it's a good idea, but until 2930 came along, there was nothing to do with it. And so it's like, well, we're all going to engineer this building block that we're not going to use. That seems silly. And so 2930 was the first thing that's going to use that building block.
Yeah, and those are for Berlin. Those are for Berlin. Just context for people listening.
Yeah, I think that's pretty interesting. I think that's some good advice on moving EIPs forward. This made me think of another question, but as an EIP editor and as an author of many EIPs, what is your feeling of the permissionless of the upgrade process? And this is also kind of a question for James as a hard fork coordinator. But what are your guys' feeling in terms of, are there gatekeepers of this process? Is it very difficult for someone who is not a part of the community who has a good idea to make a change to Ethereum? Or do you think that there is too much gatekeeping or bureaucracy in that process?
And do you want to start, James, or do you want me?
Yeah. I'll go for this one.
Okay.
I wouldn't say there's a lot of bureaucracy, because that bureaucracy has a sort of formalization of processes you need to do in order, or hoops to go through, which there isn't like a very well-defined way of approaching many of these things. So, but saying that because there isn't very well-defined ways of approaching these things, then it means it's difficult to approach, and it takes a lot of time to figure out. And there is like pre-knowledge and context. Like if you didn't, like the thing that I just said, that if you're trying to do an optimization, but you don't also have something, then it's not likely to go in. Like that's not written anywhere. But if you went on a call and suggested a change, but then also didn't suggest that little piece, then you would get that feedback really quickly. I don't know if that exactly answers your question. It's like kind of frustrating being in the process, because
yeah, I mean, it's more just talking. No, I think you're doing an okay job. I think it's more just talking about there are critics of the process. Obviously, it's a very difficult process to get the right balance of, pushing upgrades to Ethereum, not letting the protocol stagnate, but also balancing with security concerns and ensuring that we are building a protocol that's going to last 10, 20, 30, 100 years.
Yeah, I agree with what James said. There is no official process, and therefore, technically speaking, there is zero bureaucracy. But
there's plenty of barriers.
Non-technically speaking, one might look at this. Yeah, one might look at this and say, "Oh my God, that's just all bureaucracy." But technically, it's not. There's not, because you can only have bureaucracy if you have an official process. But yes, there are lots of barriers. Like there's lots of foreknowledge one needs in order to get an EIP through. And there's, unfortunately, this foreknowledge is not like things that are easy to write down. And I think cat herders are trying to do this. They're trying to document that not process. Not so we can make it an official process, because that would mean we'd have bureaucracy. We don't want bureaucracy. But just so people who are coming along can hopefully have a little easier time. Like they can go reference the material and get these little nuggets, like, oh, if you're going to introduce a EIP like 2718, make sure to also have something to go along with it that uses it. Like that's a little nugget of wisdom that someone who's been in this process might know, but someone who's not wouldn't. It's not an official bureaucratic step, but it's a good idea. We recommend this. We've seen this pattern in the past of these things got through, these other things did not get through. I'm not a core developer, and so even though I go to core developer calls sometimes, and I do EIP stuff now, I don't come from a background deep in the guts of Ethereum. I come from a background of writing applications for Ethereum, so an app developer, as it were. And so it is possible to approach this process as a non-core developer. But it is also hard. Like I had to learn the hard way, what the process or not process was. I had to show up to core dev calls, listen in on them, try to understand why things were the way they are. And contrary to popular belief, things are not the way they are just because we hate efficiency. They are the way they are because there's a bunch of different things contending. This isn't the right discussion forum for it, but there's lots of different things that people want from Ethereum, and one of those things is censorship resistance and permissionless, and those often contend with what one would see as an efficient process. Most efficient processes have someone at the top who's making decisions. And that's kind of against the ethos of Ethereum, where we don't want someone at the top who's making decisions. We don't want a shot caller. We don't want someone who's saying, this goes in because I say so. And so because of that, we don't have that efficiency that you'd get from like a traditional company. But it also means that we don't end up with a centralization problem that a lot of the people in this ecosystem are trying to get away from. Like we're trying to get away from, one person calling the shots or one person having the ability to censor someone else. And so this can kind of creates a tension between efficiency, where you want to get things done, and at the same time, you don't want someone in power. Like we don't want to create that power that someone could then seize later. Like, so maybe we all trust Vitalik today, but he's not going to be around forever. And when he's not, someone else is going to take his place. And when that person comes around, they may not be as benevolent as he was. And so by creating that power structure, we're creating an opportunity for someone to take over later. And we don't want that. And so it's not just because we hate efficiency. I know it seems like that sometimes. I've sit on calls, I'm thinking to myself, oh my God, just someone make a call, please.
Or is this a subtweet about the BLS precompile? So the EIP editors, and then people like Hudson and I, we're trying to make it so you don't have to rely on us. I had this thought of like an analogy of why part of this is kind of opaque, because anyone really can jump in. It's like we have it's like Ethereum is like a giant mansion, and there's like water slides and a pool and a theater room. And then in the basement, there's a boiler room, and just not a lot of people go and hang out in the boiler room when you're in a giant mansion having a party. So
that's where I go to hang out.
Right. So you and I and a couple other people, there just isn't a lot of people that sit in there long enough to see it through. What I see is a lot of EIP authors come in, they figure out what they need to do, they do an EIP, and then they're out doing all the other stuff they want to do. And there's just not a lot of incentive or people willing to sit in the boiler room long enough to get a sense and feel for it.
Well, thank you so much. This was all interesting conversation about not only about the proposal, but also about the process that I have been meaning to have this on the Peep and EIP show, because this is all about proposals and process improvement. Coming back to EIP-2718, this is one of the building blocks for changes that are being proposed in the future upgrades, and it's currently in the bucket list of YOLO V3. So my hope is with this episode on EIP-2718, it will be helpful for community to better understand the proposal and see what's coming up in our future upgrades. We thank you very much, Micah, James, Lightclient, to join the Cat Herders on Peep and EIP and talk about this proposal. And we also went a little off tangent to talk about some of the process upgrades thing, and I'm very happy about that. So yeah. People watching us on YouTube, you may find Twitter handle of today's guest and the rest of the participants of this meeting in the description section below. If you have any question, comment, or concerns about this or any other proposal, or have any suggestion on which proposal to be included in next hour's show, please leave a comment. And you can also reach me on Twitter at Pooja Ranjan19. If you like this episode, please share it with the other community members and let them know about Peep and EIP. see you all with Sam Wilson and Ansgar Dietrich to discuss about EIP-2938 account abstraction. Till then, keep sharing your love with us. This is your host, Pooja Ranjan, signing off. Thank you, everyone, for joining today.
Thanks, Pooja and everyone.
Thank you, Pooja.
Here's
Yep. Thanks, Pooja. Thanks all.
Before you stop recording, don't tweet at me. I'm currently boycotting Twitter, so I won't get it.
Okay,
Use our
sure.
R&D Discord then, or I guess just GitHub, right?
I mean, you can let us any
GitHub
place
or
yeah, any,
Discord.
yeah, wherever people can follow you or maybe ask some questions about this or any other proposals. That's fine.
Sure. Okay.
Nice having
Thank you very
nice
much.
talking to everyone. Thank you, everyone.
Cheers.
Mhm.
Bye bye.